Every single day, modern organizations send billions of standard email notifications for basic event registrations, schedule updates, and daily reminders. These messages are functionally inert. Once sent, they cannot be updated, they offer no native tracking, and they rely entirely on the recipient manually moving data into a separate application. Shifting this logic to dynamic calendar invites changes the nature of the notification. By utilizing standard calendar clients like Google Workspace or Microsoft Outlook, the notification itself becomes a functional user interface that the recipient already owns and understands. The calendar invite server uses serverless AWS primitives, allowing organizations to track invites through their own accounts, reducing bills by 80%. Efficiency comes from clients natively performing create, read, update, and delete operations. Let's trace a payload through this CIS pipeline. This architecture converts a one-way notification into a dynamic, fully trackable data object, while removing the overhead of traditional server management. The process begins when an event organizer sends an initial invite to a specific ingestion address. On the far left of the diagram, AWS Simple Email Service, or SES, acts as the gateway, capturing the raw, unstructured payload from the inbound invite. This capture triggers the Extract Transform Load disassembly phase, known as ETL-in. An AWS Lambda function parses the raw payload and extracts the core calendar data points. The data is then separated for storage. Large, unstructured artifacts are routed to an Amazon S3 bucket. Simultaneously, the structured state, whether the invite is a new, update, or cancel request, is written into DynamoDB. Using DynamoDB here ensures low latency, no SQL querying, which is required for rapid state retrieval later in the pipeline. This ETL-in phase successfully converts a messy email protocol into clean, decoupled storage, ready for programmatic use. Before the system can dispatch the data, it must be normalized for different external requirements. The data can serve several business contexts, from embedded web pages to direct mailing lists and automated billing systems. When one of these use cases triggers an outbound request, the system initiates the Extract, Load, Transform phase. The ELT Lambda pulls the fast state metadata from DynamoDB and the associated heavy assets from S3. The Lambda then reassembles these components into a highly personalized standard iCal payload. This payload is tailored specifically to the requirements of the recipient's calendar client. This ELT-out architecture ensures that every outbound invite reflects the most current single source of truth data stored in the database. The reassembled payload is dispatched via the AWS SES RAW API. Because the payload follows standard protocols, clients like Outlook or Google Calendar process it natively without requiring the user to install additional software. The recipient can respond yes, no, or maybe directly through their own calendar app. These RSVP actions generate responses that flow back into the CIS pipeline. This data loops back to update the original records in DynamoDB, completing the CRUD cycle. For organizations to act on this data, it must be exposed to developers and domain owners. AWS API Gateway provides a secure entry point to access this telemetry data. There are 9 specialized APIs available for developers to query this information. These endpoints allow for detailed tracking, from individual invitee status to aggregate statistics across an entire domain. This continuous loop creates a bidirectional, highly observable data pipeline that provides immediate feedback on every sent calendar invite. The entire system architecture functions by decoupling the user-facing calendar client from the AWS-based processing backend. By utilizing only managed services like Lambda and SES, the system operates without the need for manual server maintenance. This serverless approach scales automatically to accommodate millions of invites without requiring the organization to provision additional hardware. Because the pipeline is deployed as a CloudFormation template, it can be fully configured in a user's AWS account in roughly 1 hour. This deployment model ensures complete data sovereignty. Because the system resides within the user's AWS environment, the domain owner retains exclusive control over their user lists and telemetry, rather than handing that data to a third-party vendor. By refactoring notifications into a serverless pipeline, organizations can manage massive scale, reclaim their data, and maintain full observability at a fraction of legacy costs.